the recording. So what we will be learning today is introduction to NumPy. I guess I have shown it in the last lecture of derivatives. I did not show it fully, but I will show it today. And also, like, we'll learn a bit about ML. So I cannot dive in ML directly. I have to show some basic, like not a theory actually, like basic terms which you'll often see. Yeah, yeah, exactly, exactly. You mean you are saying the way I speak, right? Krishna, hello? Yeah, yeah, I always like, yeah, yeah. I have used it right now also. I don't know why I use this word, but anyways, thanks for pointing it out. So today we'll be learning NumPy. So NumPy is basically numerical Python. That means that you can use it in many kinds of numerical operations in Python, which can be like this is mostly used in data science, AI, and machine learning. Also, it is used in like some kind of, let's say for example, finance. Yeah, that's a good place. NumPy is heavily used in finance, so this is its basic use. So I guess I have taught you about this thing, like arrays and matrices. I hope I have taught you this thing about matrices in, I guess, like a week ago. Just can you all like recall? I've taught a bit about matrices and derivatives. So basically, like NumPy is a kind of library where you can deal and perform mathematical operations basically on these kind of things, matrices and arrays. Thanks, man. Thanks, Krishna. Krishna. Thanks. Like I'm really grateful. And one thing also, like you are a school student and your school has opened, but still you are joining like the session. You are trying to join. That's one thing I really appreciate because most people, they don't have any kind of summer vacation. I guess, like they are having summer vacation, but they are still not joining. But you are like very tired right now, I guess, but still joining. Anyways, let's go. So before I go into like, let's say for example, NumPy 6 a.m. to 30 p.m. with 5 hours of sleep. You have to sleep more. Don't sleep at around 1 a.m. Let's leave this. Let's go in NumPy. So before that, I will teach you one thing. Just keep your eyes. Just like I'm giving 1 minute to you all. 1 or 2 minutes. You all like bring your notebooks and pencils or pen, whatever you have, or your online note taker. Just bring it. I'm teaching a very important mathematical operation. That thing you will be always using, like, you should know this thing. I'm just waiting. Let me just pause the video. How's recording? Okay, I hope you all have like done this thing, like, not- so I will be like now teaching you about matrix multiplication. So how many of you like know about matrix multiplication? You can all type in the chat. You don't know this. So there are actually two types of matrix multiplication. One is like, it's not like matrix multiplication, you can say it like scalar multiplication, and another is matrix multiplication. So before I teach you about matrix multiplication, the real matrix multiplication, let me teach you about scalar multiplication. So let's say for example, let's take a matrix A that is, you know, let's take 2 1 0 1 1 3 2 6 8. So a scalar or a dot, let me just check, is scalar and dot products the same? Yeah, they're exactly the same thing. Yeah, as I was saying, the scalar or dot multiplication means that you are multiplying a kind of matrix by an array by a scalar. Scalar can, like I explained in the earlier class, that scalar can be any number which is not a matrix. That's, for example, let's take 23 or 2 or 1 or 0. So what if I use this thing 2a? That means I'm basically doing the dot product, or scalar product means I'm multiplying matrix a by 2. So what will be the result? That is very simple, because you just multiply all the elements inside the matrix like this with 2. So that will be 4, 2, 0, 2, 2, 6, and 4, 12, and 16. That's it. That's pretty simple, right? That's the entire thing about scalar multiplication. That's very, very simple. That's not hard at all. Just multiply all the elements by, any kind, whatever scalar you have. But now what I'm going to be showing you, this thing is like good, but this thing, what which you can see, this thing is used in AI. This is literally the backbone or the fundamental of AI, neural network, and deep learning. Let me just check, someone has joined. Okay, okay. This matrix multiplication is literally the, backbone or the main thing about neural networks and AI and deep learning, especially. So you must know this thing. In Python, let me just open a kind of, let me just make a new notebook. It was day 13, I guess. It would take a bit of time, you know. Okay. Let me just name it as 13. So basically for multiplying matrices. Yeah, I'm connecting, don't worry. Let me just zoom the thing. Matrices. You basically use this thing. You basically use add rate function. Not function especially. You use this operator, add rate. So let me just convert it into markdown. Um, how can I convert it into markdown? Mm, let's make it. Okay. I'm just like making it a comment. So just remember that in code you use this thing, this add rate symbol. So this is a scalar or dot multiplication, which is very simple. Now the main thing which comes is matrix multiplication. Matrix multiplication. So I guess I have taught you, yeah, I have taught you about, the dimensions or the order of a matrix. That means it is in the form of m comma n, where m is the number of rows and n is the number of columns. So let's take for example, um, what can I say? A. This can be like, this, and its order is, let's say, m comma n, and B, which is, let's say for example, this, and let's take for example that is A comma B. So for any kind of matrix to be multiplied, just always remember this thing, that for matrix multiplication, the row of the first matrix, and I mean like the column of the first matrix, the dimension of the column of the first matrix, and the dimension of the row of the second matrix should always be equal. So for matrix multiplication n should always be equal to a, that they should always be equal. This and this may or may not be equal, that doesn't matter, but the column of the first matrix and the row of the second matrix should always be same. Remember this, okay. So I'm gonna be showing you by code. Let's take for example import complete. Let's take for example two matrices. Let's take for example what can I say? A is equal to numpy, a is equal to numpy of array bracket the 12 so mark 2. I'm just using a very short, like a matrix. I'm not using a very big matrix. 2 comma 1. This is matrix A. Let me just put here. It should be correct. Yeah, it is correct. And let's take for example B is equal to numpy dot array. You all like try to do this with me if possible because it's an important thing. Let's take how many columns are there? 1, 2, and 3. So let's take 12, 4, and 23, 2. We're gonna enclose it within a bracket. I'm sorry. And then close the entire thing with a bracket. Okay, so here is matrix A and here is matrix B. So let's say, let's just take a note. What was the thing? Not len actually. Uh, a dot n dim. Sorry. Not n dim actually. It's shape. Okay, it's a 2 comma 3 matrix. That means basically 2 rows and 3 columns, 12, 13, and 2. And let's take another example. Let's say for suppose b dot shape. It's 2 comma 2. So just keep in mind that, let's take a new note. A has dimensions of 2 comma 3 and hashtag B has dimensions of 2 comma 2. This is a square matrix by the way because the number of rows and columns are equal. Just remember this. Now do you think the two matrices will multiply if I multiply A with B? Do you think will they multiply? Just type in the chat. Let me just try it out myself. A multiplied by B result is equal to A multiplied by B. Let's just check once. See, yeah, the thing is that, which I told, now I guess this thing is connecting because what I've told, for a matrix multiplication, the column of the first matrix and the row of the second matrix should always be of the same dimension. Let's say suppose this is 2, then this should also be 2. If this is 3, that should also be 3. The other these things doesn't matter too much. So now as you can see, the dimension of the first the column of
Yeah,
the first matrix, that means matrix A is 3 3 dimension, not 3
nice.
like the number of columns is 3. But in matrix B the number of columns, I mean the number of rows is 2. So since these things, like the column of the first matrix and the row
मैंने
of the
बोल क्या
second
कहना है?
matrix aren't matching, so this won't matrix multiply. That's the main thing. Remember.
Sheets climate trigonometric view.
Huh? What did you say, Krishna? Krishna, your mic was open. If you wanted to say, you can type in the chat, but please don't use the mic. Now, let me just show you one thing. Um, is matrix multiplication commutative? So you must know the fact that commutative means that if a number is r is equal to a multiplied by b, then r should also be b multiplied by a. That's a commutative property of multiplication. But here you can see that matrix multiplication is generally not commutative because, see, if I try to multiply A with P, matrix A with matrix P, then the matrices won't multiply because the dimensions, like the column of the first matrix and the row of the second matrix aren't matching or aren't the same. But if I try to do B at the rate A, that means B matrix multiplication A. You know that this is a matrix multiplication sign. So now just check this is happening because matrix multiplication is generally not commutative. So AB is really equal to BA. That's what I'm trying to explain. I hope you all can understand, right? Now, if we try to print the result, here you can say this is this is the thing. But if I again try to use the commutative order, then let me try this thing. Then you can see that's the main thing. So I guess I won't be holding much into matrix multiplication, but I guess you all got the core idea, right? That means that matrix multiplication is not not commutative. Now just check. One when I tried to do this thing with a multiplied by b, then it was an error. But when I tried to do with b multiplied by a, it wasn't an error, and instead it was a correct matrix operation. So just keep that in mind. And also always keep a check on the dimensions. That's why you will always see that in neural networks and so the first layer is the number of inputs and then this thing, and the second layer this thing and this thing should always match, and the other output you can make it by yourself. Let it be 3, let it be 6, whatever. But the other thing which will be there should always match with this thing. I hope you all understood about matrix multiplication, right? Just type in a chat if it was yes or no. Just type in a chat. Okay. I will not be teaching like a maths teacher here because the main goal is machine learning. So let's go in NumPy. No more, no more matrices. Just remember that the symbol for matrix multiplication is at rate. No issues, Krishna, by the way. Just next time, just don't forget to close your mic whenever you are trying to talk with someone. Or it is advisable to keep everyone should keep their mics closed the entire session. Haha. That's a strange fact. Who knows? Anyways, let's go. So numpy.array, I guess you all know. Yeah, it is the third time. I It is the third time, exactly the third time. I've actually noticed how much time you have how many times you have opened your mic. I hope you don't feel offended. I have a weird habit of checking these kind of small things. Anyways, let's go. So let me just clear up this thing. তোমাৰ ভলিউমটো কমোৱা Volume no comma. Okay, let's go. So now we will go to creating arrays. So arrays are basically matrices, but you can create as many arrays as you want. Let's say, for example, array is equal to. Let's make a 1D, 2D, and a. Sorry for. Just sorry. Let's make a 1D array, um, 2D array, and 3D array. And let's try to make a 4D array. Okay, 4D, I might make some errors starting from here, but the 2Ds and 1Ds will be like correct. So, like I'm giving 30 seconds for you all to like make your code editors or whatever you are coding in like ready so that you all can code alongside me. Just be ready. I'm giving 30 seconds, exactly 30 seconds. Just comment this up. 2D. I guess you all have done your code editors ready, so I can like go to coding. So let me just make one here, 2D, hashtag 2D, uh, hash, hash, hashtag 1D. So let me just cut this off. Mm, 1D is equal to numpy dot array. That's pretty much simple. Just do it like this. I don't know what's the issue here. That shouldn't be wrong, I guess. Yeah, it was wrong. So let's say we have 1 underscore D. This should be correct. No issue, Pratik Jaiswal. You can like take care of yourself. That's what I'm trying to say now. No issues if you like cannot write or something. Just take care of yourself, and I hope you get well soon. NumPy array. That's very simple. If possible, yeah. But this code, I guess that I will give you a tutorial video. Okay, that would be much better. This is simple. This is just a 1D array. So you can go here and 1 underscore D dot mdim. And if you like try to print it out, it's 1. That means it's a one-dimensional array. Now let's go into two-dimensional array. So 2 underscore D. I don't know what's the issue in writing 2D because in regular Python it's not the issue, I guess. 2D is equal to let's say for example numpy dot array. And also always remember that you should and you know the there is only one kind of bracket. There is only one color of bracket. That means that it's a 1D array. And there are two colors of bracket. That means that this is one bracket, one close bracket, this is another close bracket. So if there's one close bracket, then it's a 1D array. But if there's two close brackets, then it's a 2D array. And if there's three close brackets, there are 3D array. Don't hide your injury with from parents, bro. Like just admit to them because you know, like just admit to them. I like yeah. Just tell your parents that you had an injury and they will like help you in some kind of medication or like helping or so. Let me just show you once if it is true or not. Like the number of let me just type this thing. Number of closed square brackets in array is equal to number of dimensions in that array. I'm just checking it here because I might be wrong. Yeah, you can see number of pairs of square brackets using declaration. Pairs or closed square brackets, you can write whatever. It's the same thing. So now let's go here. Let me control X, control V. Okay, now let's go. 22, 21, 22, 23, 32, comma 2, comma 1, 1, 2. Oh, volume to কমোৱা oh, volume to কমোৱা volume কমোৱা and let's create this thing also another just don't forget to like give the commas are really important or else your thing will be wrong if you're ending your array then it's a different thing then you don't need commas essentially but in the middle of the array or starting an array just give commas and to reach this too that's another kind of array since there are two close brackets the first close bracket is the blue bracket and another is the this bracket so this would be a 2D array just in case let me just check and yeah it's exactly so let's make a 3D array this is a bit confusing by the way I myself get confused 3 underscore dim is equal to let's let's go 3 underscore d is equal to numpy dot array I hope you all are coding alongside with me because you know like excluding Pratik Jaiswal, I hope you all like are coding alongside with me. So it's a three array because they are basically like you know close brackets, three pairs of brackets, one, two, and three. So let's start with this thing. This is one thing. This is very confusing, you know. When it's zero, zero two comma. I myself got confused here. Zero. Let's go here. I guess I'm myself getting confused to be honest. It's a 2D array. Yeah, now I understood. Now I understood. Okay, 23, 1, 2, 2. I don't know why I'm using the number 23 so much times. And that's 1, 0. I forgot to give comma here. Yeah, this thing. So this is a 3D array. This is a bit hard to interpret because inside it this is a 1D array, this is a 1D array, and inside this bracket it's a 2D array. And this 2D array is collectively inside this thing. So it's a 3D array essentially. So let me just check here. 3 underscore d dot n dim. I might be wrong also. It's a 3D array, yeah. You all can see, right? That's it. And 4D array, just like try to put another square bracket here, and that's yeah, that's a 4D. That's how simple it is to create arrays. But basically, you know, just keep it to 3D arrays. Now making random columns. Let me just take a sip of my coffee. Till then, you're like, just say this. Let me just fix. Till then, check the code. Let me just drink some coffee. We have gone actually very much right. In just a short time, we have covered so many things, and I guess like by the 22nd, where the cohort will officially end, we will at least make a kind of machine learning model, if I'm not wrong. And for machine learning models, I will like give make a GitHub repository, and Also, I will not be coding here, I guess, for making machine learning models. I'm just showing you for demonstration. But for ML models, I will be using this VS Code or anti-gravity if the agent is there. Let me just drink my coffee. Anyways, just dive in a. Anyways, let's have a quick coffee chat. Like, are you all watching football World Cup? Because today I will like, I guess I'll study till late and I will then watch football World Cup. I guess today's night match is between France and Paraguay. I did not say this, Krishna. I said VS, both are good. VS Code is good for production and Colab is good for like visual demonstration and like for testing. So these kind of things where I make these things are basically testing because I'm showing you for a representation like these things. But for VS Code, you officially like make things strictly out of production. Got it? You can use Colab also, no worries. But since I will be like publishing it on GitHub, so I will preferably use this VS Code. Anyways, are you all watching World Cup? Just type in the chat. No, 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 no. I don't use paid Claude. I don't know. I like the free version. And I don't like its rate limits much, but Claude is very good. And anti-gravity, yeah, I have its paid plan. Actually, I love anti-gravity. I guess Gemini is actually better than Claude ATP because its rate limits are higher and you can use it many times and it's very flexible also. Claude hits the rate limit like very soon. Yeah, same. I also got anti-gravity CLI. It's Gem. Which one? You are talking about this or what? Wait, terminal, yeah. Terminal based, yeah. That's not anti-gravity, I guess. That's a Gemini CLI. Anti-gravity is very good. I love it, man. I don't like cursor. I like anti-gravity much. Oh, they are different. So I was wrong, I guess. Anyways, let's go. Making random columns. So calls is equal to not columns, sorry, arrays. So random arrays means like you don't fix the arrays. The arrays are arranged by the machine, not machine actually, the library where it can be any number like X, Y, Z, A, B, C, blah, blah, blah. CLI, yeah. But CLI experience feels a bit different. It feels like a hacker. Array is equal to numpy dot. Now you will use this method random dot ren. Now you will type the number of dimensions which you want. Sorry, it was rand. Now just type the dimensions. It can be 23. Let's take for example 4, 3, where the number of rows are 4 and columns are 3. Array. See, it's totally like 4, 3, and these are total random arrays because I did not make these up. These are basically random arrays because you you basically don't set it. They're decided by the array numpy random function itself. So basically this thing. And now this random thing won't like be of much use. But when you are using in deep learning now, then there is a specific term. You might not know this now, but this is called weights. They are basically random. It can be blah 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 blah. And these are arranged, these are like fixed so that they become good for the model and they can be like mathematically used in neural networks. And what's the array and the end? They, it should also be the same. Yeah, they are also the same. Random is also the same. Ran is also the same. And if you use ren int, that means that the things will be directly integers, I guess. Wait a minute, what happened? I guess this should be like this. I don't know what happened. Anyways, I don't use it much. Forget this. But always remember that for creating random arrays, you can either use random dot rand and type the number of dimensions. You can name anything. I will just name it 1 1 2, and or hashtag, or you can use array is equal to numpy dot random dot random 1 comma 2. What are essentially the same. There might be a slight difference, like there might be slight difference between the rand and random, but basically they are both the same. You can use whatever you want. And now just go here. Here's the outputs. Okay. Now creating hashtag arrays with zeros. So this is very simple. 0 is equal to numpy dot zeros. It should be zeros, yeah. And again name the dimensions, whatever shape you want. Just try to put it up in a bracket or in a tuple so that it's a shape. So inside this argument it should be, not inside this. So let's go here and let's type 0 and it should work. Yeah, see, 12 comma 2, because there are exactly 12 rows, 1 2 3 and till 12, and 2 columns, and all are zeros. This is basically used in setting up biases, and I forgot to mention it, for setting weights. Or you can like, wait, let me just check it. Or you can also do it like this in a tuple, I guess. No, it's a wrong. It is wrong, it is wrong. It should always be 1 comma 2. I hope you all got it till numpy dot random and numpy dot the zeros. Just type in the chat. Ah. Sure, hang on. Allah boleh ko. Okay, let's go. So basically, just remember that numpy dot zeros means you are just filling up the entire matrix with zeros. Here you can like type here like this in a sequential order, but here you have to name the dimension as a tuple. And now let's go with arrays with ones. This is also very simple. 1 is equal to, I don't know what is appearing. Cancel. I don't know why your savior changes. Okay, let's go. One is simple. Numpy dot ones is equal to, um, let's again here you have to write in a tuple because it's a shape. If you try to write like this, one element like this, then this it would fall in a D type statement, which is totally wrong. Comma 2. Then it will simply like like the entire array will be filled with this one row and two columns. That's it. Very simple. This is used in like setting up weights. You can either use numpy.ones or numpy.random. Ideally random is used, but you can also use numpy.ones, not an issue at all. Now let's go. What should I say? Now you might be thinking like what are weights and what are biases? I will be teaching it right. I will be teaching it today only. Got it. So I hope you will like just keep a clear intuition of it. I'll be teaching it in the most simplest way possible, by the way. Let me just drink my coffee. Okay, let's go. So there is another thing where you can transpose. So the transpose of matrix is basically, let's say for example, this is a matrix A, comma B, comma C, comma D. So basically flip the matrix from this step. From this you flip in this direction. So basically it will become like, B, comma D, comma B, comma D, comma C, comma A. It will be like this. So basically, like this, let's say for example, this is the this. This is the rows, this is sorry, this is the columns and this is the rows. So basically it will be the columns and rows will shift. That means that the columns will become the rows and the rows will become the columns. That's the simplest thing. That's the entire transpose things. So transpose basically means that transpose of a matrix means that you simply make the rows as columns and columns as not like, let me just use an arrow sign because you don't actually equal both of them. You transform the rows as columns and columns as rows. That's it. Let's take for example not a square matrix because that would not be very understandable by you all. 2 comma 1 comma 0 comma 1 comma 2. uh, let's keep it like this. Let's cut this off. 0 comma 2 comma 3 comma 0. So here the rows is 1 2 3 and 4. 1 comma 2. So now this is matrix A. Now the for transpose you use the big T on the this thing, on the power. It's actually not a power, but you usually use the big T in the power notation. That's but there is no power operator used actually. So it will essentially become like the rows and columns will be flipped. Transpose means flipping a matrix especially. So that would like be somewhat like 1 0 then 3 2 0 and then 1 0 1 2. See, you basically flip the matrix. That's a bit hard to visualize and understand, but I hope you can visualize because I cannot like show it in a much more like visual way. You can watch in YouTube about this, but I won't be teaching it much. But just let me just check the transpose of this matrix. Transpose of matrix. No, I can use in NumPy also. Why am I doing it like this? So for transposing a matrix, you basically use trans is equal to, let's make an array. Um, C is equal to, let's take for example C only. NumPy dot array bracket. This is a 2D matrix what I created. This and in. Yeah, exactly. You can say it like this. I'm not. Yeah, you can say because I'm like trying to show the visual way or the like how it's done. So this might look hard to some people. You are right, Rakshit. You aren't wrong. Let's make a matrix like 2 comma 3 comma 4 45. That will also work. 1 comma 2 comma 3 and 12 comma 0 comma 1 1 comma 1 comma 2. Now what I want to do is to to transpose or flip it. It C dot trans is equal to you have this thing, big T. You basically use this thing, I guess. No, it is wrong. Oh, sorry, I forgot it. Now you can see the entire matrix is transposed, but it is not a function. It's a kind of attribute of an array. So, like, it's a kind of thing which is written inside the initializer of the, NumPy array object where, that D thing is a kind of attribute where this thing is flipped. Or you can also let's try transpose. That will also work. It's a method. Basically the same thing. You can use transpose or T. They are basically the same thing, but in T you don't use this thing, you don't use this parenthesis, and in transpose you use a parenthesis. That's the main thing. Now entire thing of NumPy is done. Now we'll basically, there are many kind of functions in NumPy which I won't be teaching it. Let me just teach one more function. That means that is numpy.clamp. Numpy.clip, sorry. It would end at 6. At around 6:10, I guess, 6:10. Numpy.clip. That means that, let's say for suppose, you want a particular matrix to be at a certain range. Let's say for suppose 0, comma, why am I using comma by the way? 2, comma 10, 1, comma 9, comma 8, 3, comma 5, comma 2. So you don't want them to be scattered. You want them to be in a range of, like, let's say for example 2 to 10, no, 2 to 12. So the numbers which are closer to 2 will become 2, and the numbers which are closer to 12 will become 12. So this is closer to 2, this is closer to 2, this is closer to 2, this is also closer to 2, and this is, I guess, 5 is also closer to 12, 2, I guess, and others are closer to 12. This is like close to 2 because 0 is close to 2. So basically when I apply the clip function, basically it becomes like, in a certain range. When I use clip A in the range of this thing, in this range. So what I'm doing is basically like either making it 2 or 12 based on the approximation or the round off. So 0 is closer to, so this will also become 2, 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 this will become 12 because 9 is closer to 12. This will also become 12, 2, 12, 2. So basically you are like rounding off to the extreme most values. So I'll show you my code. Let me just copy it and numpy.clip. Let's take for example this matrix looks, let me just make another better one. Okay, so let's go. So to suppose I want to like clip them between 2 and 10. 10, let's say we're 14. 2, comma 7, comma 12, 0, comma -1, comma 5, and let's say for example this is a, I have used the numpy clip function like very long time ago, so my thing might be wrong also. So let's go here, let's say -10. 9, and let's name it as 8. 8 would work. 5, 6. So what I would do is numpy.clip. Now you can see A. A means that, A is basically the matrix which I'm referring to. Here A should take the n property. So, A will be n because that's the matrix which I'm referring to. And now A minimum, that would be 2, and A maximum will be 14. I guess that should work. Oh, sorry, I forgot to explain this one thing. Like whatever is more than, I forgot to explain this thing. Sorry. Whatever between 2 or 14, if this is less than 2, then it will become 2. And if this is more than 14, then it will become 14. The middle values will remain the same. Sorry. I did not use this thing for a long time. So just remember this, that, whenever I clip it, the things which are less than things which are less than A will become A, and things which are more than B will become B. Just remember this. Okay. Sorry. It's my fault totally, and I understand this. So let's take, for example, -1, and then 0, -23, 91, 52, and then 62, and then now you can see this thing is less than 2, this thing is less than 2, this thing is less than 2, and this thing is also less than 2. But these are more than 14, these are more than 14, these are more than 14, and this is between. These numbers are between. So if I try to do this, see, whichever number is more less than 2 are becoming 2 because this is clipping, and whichever numbers are more than 14 are becoming 14. But whichever number are between the range 2 and 14, they are simply the same. They haven't changed. So I hope you understood. So this is clipping is to maintain a certain range between two sets of different things. Hydrogen oxide. You mean H2O? H2O, it is called dihydrogen monoxide, not hydrogen oxide. I guess, the clipping means to maintain a certain range between two sets of different numbers. Mean less be will CD value become max. That's it. Minimum is the 2, maximum is the 14. So they will be clipped. Hydrogen oxide is wrong actually. Hydrogen oxide. Oh, it is correct. It is correct actually. Correct. But dihydrogen monoxide, dihydrogen monoxide. It's also correct. Hydrogen oxide is actually correct because, um, hydrogen has a valency of +1, and oxide has a valency of -2. So if they both cross each other, then it will become H2O. So you are correct. And dihydrogen monoxide is, I guess, is organic. It is inorganic. Dihydrogen. You can also name it as dihydrogen because there are two hydrogen atoms. So it is dihydrogen, and monoxide, one oxygen. So it's monoxide. But if you are naming it by inorganic nomenclature, then it would be hydrogen oxide. You are correct. Hydrogen oxide. why am I teaching chemistry, by the way? Okay, let's go. So I hope you understood the main functions between of clip, etc., etc. What happened, Krishna? Say. Krishna, say what happened. Just type in chat. Yeah, I was saying the same thing. I knew you were having water. Of course, man. I also study chemistry. And the valency of oxygen was, I guess, 2, because it has like, let me just draw its diagram. Two two this two sh two shells are already filled in the K here, and like one, two, three. Its valence, its atomic number is 8. So this thing, 1, 2, 3, 4, 5, 6. This is KL. So it's 6. So it can gain extra two things. So it's 2 minus. Yeah. You are correct. Can gain extra two electrons. So that would be 2 minus. Okay, anyways, I hope you all understood what was NumPy arrays. I hope you understood, like, NumPy arrays dimensions, 2D, these kind of things, and random, zeros, ones, transposing, and clipping. Yeah, exactly. Today's thing was most about math only. And most coding and these kind of things become much more fun when you can relate them with other kinds of interdisciplinary things like physics, math, or etc. So that they make sense. Anyways, I hope you understood what I'm teaching. Not at all, man. Math is in machine learning isn't hard too much, but the formulas look scary. Clipping means, okay. Clipping means, suppose, let's say, for suppose there are many numbers, right? -1, -2. Let's take, for example, you are taking a range of minimum number should be 2. This is the minimum value. This is the clipping thing, okay, which I'm trying to explain, Amikar. And the maximum value should be 20. That is max value. And they are the elements. So they will be unchanged. The numbers between 2 and 20, because, you know, but the numbers which are below 2, like -2, -1, -12, etc. If I apply the clip function, then they will not be like this. They will become 2. And if if I apply the clip function here also, then that means that any number which is greater than 21, that's 21 or 100 or whatever, that would not become like this, but will become 20. So that means that I'm standardizing the minimum and max values. I hope you understood. See, here I applied the numpy clip function. Here is the normal array. -1, this thing. Wait, let me just change it. Here you can see the range is 2 and 14. Let me just show it once again so you can better understand. NumPy.clip. See, A means the array or a matrix we are talking to. Here A will take n. A minimum is the minimum range or the minimum value which it should be, and maximum is the maximum range. Beyond this it cannot go. So as I said, the matrix I'm referring to is matrix n, and let's take it for example 2. The minimum range and maximum range will be 13 this time. So this is less than 2, 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 this is less than 2. So this will become 2, and whatever are more than 13 will become 13. So once I apply this thing, see, whatever values are less than 2 have become 2, and whatever values are more than 13, sorry, 13 have become 13. Clipping means I'm like maintain a certain range between two sets of different numbers. Less will become minimum and exceeding value will become maximum. And the values between 2 and 13, which are 7 and then 8, are unchanged. 7, 8, 7, 12 and 8 are unchanged. I hope you understood, Amikar. Exactly, Amikar. That's the main thing of clipping. Exactly. So that you maintain a specific range so that some numbers do not get too less or too more in a data set. Let's say for example, I'm showing you a practical example. Let me just use this marker. You have a normal data set of marks. Suppose you want to calculate the average sc- score of a class. So you will take like this. The values are normal. But suppose one value becomes like this, very less, and one value becomes someone like scores this much, and like let's take it like this. Let's make it a bit long, like this, like this, like this, like this, like this, and again he's someone scores very less, 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 less. Then this is the average, and this is again very long. So what to calculate the average score? I must like standardize these things. These are okay, but I should set the minimum value to this so that these things will become like this, and the big thing which is like this will go to that range so that calculating the average will become much more convenient. I hope you got it, Amikar. I hope you got my example right. That means like you like use clipping in a dataset to prevent the spike or the downstrokes. Now let's go in the most awaited topic. This is ML. ML. So basically, this is a theory class of ML. I will show the practical soon. So just keep in mind that I'm typing. Okay, I'm very tired of drawing those sketches. Supervised learning. You use dataset. You have a defined row columns. Yeah, yeah. Exactly, exactly. LR means learning, by the way. You agent machine learns from its mistake. Error. So this is a basic theory. So supervised means you have a data set where there is a labeled data. That's you just for supervised. Just remember that you always whenever you refer to supervised, you always refer to labeled data. That means that data which is a specific label. That means this. Let's say for example, height, weight, and then age. These are the labels. This is a label. This is a label. This is a label. And this whatever you are saying 2 2 4 blah blah blah, this these are the columns. This is a relational database or label data. It has a label and it can be read especially. And unsupervised learning means you don't have any kind of label. You don't know what are the labels. This is an this is a this is a this is a cat, but there is no kind of label, like there is no written cat. This is a this is a let's say for example, this is a dog. Yeah, yeah, exactly. You not exact, not exactly, I guess, but till like you minimize the errors and learn from the trial and reward system. I won't be teaching reinforcement learning, by the way, because I'm not much specialized in this. And this is a dog. You don't know about this data. You have to find out on your own using some kind of algorithm. This is unsupervised. Unsupervised means unlabeled data. Unlabeled, which has no order, rows or columns. It doesn't have any kind of order or rows or columns. It just has a kind of data, which is this thing and this thing. And reinforcement is a bit different. I don't want to teach it here because it would be too much. So also learn these things. Epoch. You will listen or you will know this, you will hear this term epoch or iteration. You can go if you want. I'm just going on some extra rounds here. I'll teach this last topic and I will end the class. Epoch and iteration means that the number of tries. This is the first epoch, this is the second epoch, this is the third epoch. So epoch means sure, sure, Krishna, as you wish. This thing is very important because you know no problem, man, no problem. Whenever a machine learns, it never makes correct in the first attempt. Always remember this thing. This is the most important thing in machine learning. It never becomes correct in the first attempt. It will always make an error and it will always make a kind of difference from the actual output. So you loop it again, loop it again, loop it again in a sequence, in a algorithm. This is the first loop, this is the second loop, this, till the n number of loops. And then it becomes almost like, close to correct. It is never actually correct, it is actually close to correct. Nth attempt. And this entire range, this is a for loop, by the way. Epoch is basically a for loop. Let me show you practically once. Epoch demonstration. Epoch is equal to, sorry, for epochs. I'm not using epoch, I'm using epochs. That means the number of turns in epoch. X is equal to epochs. Let me just name it differently. I just did a mistake. Epochs. Epoch is equal to epoch plus 1. Oh, sorry. I don't know. Yeah, range, sorry. Epoch is epoch plus 1. This is the entire loop. You will see this loop so many times in machine learning and deep learning that you'll be almost familiar with it. Epoch, or you can also write it as iterations. Iteration. Iterations. That means I'm looping around this thing again and again till my model makes the correct decision or a thing. So this entire thing is called epoch or iteration or iteration. I hope you understood this, right? And even listen, another thing which is called as LR or learning rate. Learning rate or alpha. In mathematical notation, you will see this thing. In mathematical ML, you will see this alpha symbol. And learning rate and LR are basically used in libraries. But these three are exactly the same, not much of a difference. So basically, alpha means, I want, like, at how what rate it learns. Suppose I put alpha as, let's say for example, 1. So it will take, for this number of loops. Just remember this. I'm just showing a brief thing. That's not what exactly happens in machine learning, but I'm showing you a brief intuition. This, till the this, n. Let's take for example 0. Okay, let's take alpha equal 1. This is the first loop, second loop, third loop, till the nth. And epoch. Now, till the nth epoch, it will take this step. This is what 1 alpha. This is 1 alpha. This means that it is a number of steps that the model is taking. Steps. 1 alpha. Basically, like whenever a model learns, it is like, gradient in gradient descent, it's like this. So basically, if I take, this, if I take alpha is equal to 1, then it will be like this. It will go like this, like this, like this, like this, like this, like this, and here. And this is called a local minimum. Local minima. That means that here the errors are almost equivalent to 0. Here the errors are almost equivalent to 0. So here, when you reach it, here, it stops right here. And here, the entire range is called as LR, or learning rate, or alpha. And if I make alpha, like for example 20, then it would like shoot like this, like this, like this, and it might like bounce back so much that it might go out, and a model will never learn. Here local minima is overcrossed. You will understand this now. Just try to remember it. So alpha is nothing but the speed or the steps in which the machine is learning, or algorithm is learning. And suppose again I keep the alpha as 20, which I showed up here. So basically what will happen is that, alpha, the total loop will be like this. Let me just zoom out a bit. This is the first loop. Sorry. This is the first loop, second loop, third iteration. Sorry, this nth iteration. So this is 20. This is 20. This is 20. So basically the rate in which the model is learning or converging is known as its alpha, or learning rate. I hope you understood, right? Epoch. And also keep a quick note on, I hope you understood, generalization. Not necessarily generalization. It's not called generalization. Generalization means a different term. It's in, generalize. It's, I guess, in data pre-processing, where you use min-max scaling. Is min-max? I'm not sure. It may be called as generalization. Generalization in ML. It's not actually called generalization. It's called as, it's, I'm not like trying to show a model's ability to perform accurately on unseen data. You are correct in a sense, but I'm not trying to show this thing. It's actually called as gradient descent. This entire loop through is where epoch iterations and learning rate meet, and, from a certain algorithm, this is called as model's learning loop, or the gradient descent. Got it? I hope you are clear, Inugu Rakshit. Generation means how the model is performing on the new unseen data or the testing data. This is called as gradient descent. This entire thing, this is called a gradient descent. I can show you here also. Gradient descent machine learning. See, this is the entire thing which I'm trying to show. Learning step, minimum value. This is called local minima also. I hope you all got it right. This learning step is also called as, like alpha or the learning rate, and this entire how many steps it is taking is known as the iteration or the epoch. I hope you all got it right. It is the basic intuition, this entire thing. I hope, how was the session today? This I'm now officially ending my session here because I won't like go too much further because I have to study. How was the session? Just rate it. Yeah. Was it anyhow better or like same? Just like you all can like chat or like you all can text here, no issues.